I got some gravitation problems that you and I can do. So the first one states that calculate the gravitational force between two objects of masses 12 kg and 20 kg when they're separated by a distance of 3 meters. Now we can use the formula F is equal to G times m1 into m2 by r squared. Now if you just plug in the values, the first thing, we're going to take G as 6.67 into 10 to the power of negative 11. We're going to plug in the values. So 6.67 times 10 to the power of negative 11 times 12 times 20 by r squared, which is 3. So 3 squared is 9. Cancel. 3, 4, 3. So you get 20 by 3 times this value over here. And when you simplify this, you get this as 6.67 into 10 to the power of negative 11 times 26.67. And if you do all this multiplication, you get the value as approximately 1.78 times 10 to the power of negative 9 newtons. And that's how you do the first question. Let's move on to the second question. So the second question says that an object is dropped from a height of 30 meters. Calculate the time to reach the ground and the velocity as it hits the ground. So we have the values. We can take initial velocity as 0 meters per second. Height is 30 meters. Now first we need to find the time. So we can use the formula h is equal to half at squared. Now we can take g as 10 meters per second as it's moving down. So h is equal to half times 10 times t squared. We're going to take h as 30 meters. Cancel this. So then you get it as t squared is equal to 30 by 5, which is basically 6. Now if you move the power towards the right hand side, you get t is equal to root 6, and this is approximately 2.45 seconds. And that's the first part of the question. Now we have to find the velocity. So we can take the formula v squared is equal to 2gh. Plug in the values. V squared is equal to 2 times 10 times 30, which is 600. Do the same thing, move the square root, so v is equal to root 600. And this is approximately 24.49 meters per second. And that's how you solve the second question. Now the third question states that a person has a mass of 75 kgs, the weight on the earth and weight on moon. So we're supposed to find the weight on these two specific bodies. So we know that weight is equal to mass times acceleration due to gravity. So let's do the first one. So weight on earth. We know that the acceleration due to gravity on earth is 9.8 meters per second squared. So we're going to plug in the values. 75 times 9.8 meters per second squared, which is 735 Newton. Moving on to the second bit, we're supposed to find the weight on the moon. But the moon has a lesser gravitational force compared to the Earth, so therefore the acceleration due to gravity on the moon is 1.63 meters per second squared. So we're going to plug in the values. 75 times 1.63 meters per second squared is approximately 122.25 Newton. And that's how you do the third problem. Moving on to our final problem. It says that a ball is thrown downward from a height of 20 meters at an initial velocity of 3 meters per second. And what is the speed before hitting the ground? So we can simply use this formula, which is the third equation of motion. V squared is equal to u squared plus 2as. But since we're dealing with gravity, we're going to change it up a little bit. So it's v squared is equal to u squared plus 2gh. Now we're going to plug in the values. So we don't know v squared, so we'll just write it as v squared is equal to u squared, which is 3 meters per second, 3 whole squared, plus 2 times, we're going to take g as 10 meters per second squared, times 10 times 20. Now if you simplify this, 9 plus 20 times 20 is 400. So v squared is equal to 409. You're going to shift the square root, so v is equal to root 409, which is 20.22 approximately. I hope these problems were useful to you, and if you really like this video, please consider subscribing and leave a like, and I'll see you guys in my next video. Goodbye.